In my previous video, we have discussed equations of planes in various forms and problems based on them. In this video, we are going to discuss angle between the planes. Consider these two intersecting planes whose equations are r bar dot n1 bar equals d1 this plane and r bar dot n2 bar equals d2 this plane. The acute angle theta between these two planes is same as the angle between their normals n1, which suppose is this vector n1 bar perpendicular to this plane and this vector n2 bar perpendicular to the second plane. The angle between them theta is same as the angle between these two planes, which means that angle between the planes is same as the angle between their normals n1 bar and n2 bar. This angle theta between the planes is given by the formula cos theta equals mod of n1 bar dot n2 bar upon mod n1 bar dot mod n2 bar. The scalar or dot product between the two vectors a bar and b bar is given as magnitude of a bar into magnitude of b bar cos theta, which follows cos theta equals magnitude of a bar dot b bar upon mod a bar into mod b bar, which is same as this formula. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. Now let's see how to find the acute angle between these two planes whose equations are r bar dot 2 I cap plus j cap minus k cap equals 2 and the second plane this whose equation is r bar dot I cap plus 2 j cap plus k cap equals 1. From these equations we get n1 bar equals this 2 I cap plus j cap minus k cap and n2 bar another normal vector this I cap plus 2 j cap plus k cap. If the acute angle between the two planes is theta, then we have cos theta equals n1 bar dot n2 bar upon mod n1 bar dot mod n2 bar and the mod of whole of it, so that will be equal to n1 bar dot n2 bar will be this 2 multiplied by 1 2 plus this 1 multiplied by 2 that is 2 minus 1 multiplied by 1 minus 1 upon n1 bar will be square root of 2 square that is 4 plus 1 square that is 1 plus minus 1 square that is 1, that will be root 6 multiplied by square root of 1 square that is 1, 2 square is 4, 1 square is 1, so that will be root 6. 3 upon 6 or half, which implies theta equals cos inverse of half, that will be pi by 3 or 60 degrees because cos 60 is 1/2. So the angle between these two planes theta is pi by 3 radians or 60 degrees. Now let's understand how to find angle between a line and a plane. We have to find angle between a line whose equation is r bar equals a bar plus lambda b bar. We have seen in my video online that this line is parallel to this vector b bar. Now we have to find the angle between this line and this plane whose equation is r bar dot n bar equals p, where n bar is a normal vector to this plane. In order to find the angle between this line and this plane, we will draw this vector b bar like this. If we join the foot of this perpendicular along this plane to this vector b bar, then this will be the angle theta between normal vector n bar and b bar. But this is not what we have to find out. We have to find out the angle between this line and this plane, which means we have to find the angle between b bar and this line AB, which will be this angle, and this is going to be complementary angle of theta, that is pi by 2 minus theta. So using the formula we write cos of this complementary angle pi by 2 minus theta equals this b bar dot this n bar upon mod of p bar into mod of n bar and mod of this whole thing. But we know that cos of pi by 2 minus theta is sin theta. So we get the formula sin theta equals mod of b bar dot n bar upon mod b bar dot mod n bar. So with the help of this formula we can find the angle between this line and this plane. Sin theta equals mod of b bar dot n bar upon mod b bar into mod n bar. Now let's find angle between this line, whose equation is r bar equals I cap plus 2j cap plus k cap plus lambda times I cap plus j cap plus k cap, and plane whose equation is r bar dot 2 I cap minus j cap plus k cap equals 8. In this case, the vector parallel to this line p bar is this I cap plus j cap plus k cap, and the normal vector n bar to this plane is this 2 I cap minus j cap plus k cap. We will draw a vector parallel to b bar like this, and a line from the foot of the perpendicular cutting this vector along the plane, so that this is b bar and the angle between n bar and b bar is theta degrees. But this is not what we want. We want angle between this plane and this line, which is this angle, and this will be complementary angle of theta, that is pi by 2 minus theta. So in order to find the angle between this line and this plane, we will write cos of pi by 2 minus theta equals this b bar dot this n bar upon mod of b bar into mod of n bar and mod of this whole thing. We know cos of pi by 2 minus theta is sin theta, so it will be b bar dot n bar will be 1 into 2 will be 2 minus 1 into 1 minus 1 1 into 1 plus 1 upon mod b bar will be square root of 1 square plus 1 square plus 1 square, that is 3, into square root of 2 square, that is 4, plus minus 1 square 1 plus 1 square 1, so that will be root 6 mod of 2 upon root 18, that will be 3 root 2. So sin theta will be root 2 upon 3. So theta will be sin inverse of root 2 upon 3. So this will be the angle between this line and this plane. Now we will study how two lines are coplanar and what is the condition of coplanarity of two lines. When two lines are parallel, they pass through a single plane, hence they are coplanar lines. But when they are non-parallel, like these L1 and L2, they must intersect in a single point P. Then only these lines L1 and L2 coplanar. Or in other words, we can say that the shortest distance between L1 and L2 is 0. Now let us draw line L1 which passes through point A, whose position vector is A1 bar and which is parallel to vector P1 bar, and a line which is not parallel to L1 is this line L2 which passes through point B, whose position vector is A2 bar and which is parallel to vector B2 bar. Now cross product of B1 bar and B2 bar will be a normal vector, say n bar equals B1 bar cross B2 bar, and vector AB bar will be A2 bar minus A1 bar. Now if the situation is like this, there is a normal vector n bar equals B1 bar cross B2 bar and vector AB bar which is R bar equals A2 bar minus A1 bar. Then vector equation of the plane will be R bar dot n bar equals 0, which implies lines L1 and L2 will be coplanar if A2 bar minus A1 bar dot B1 bar cross B2 bar is 0, and this is the condition of coplanarity of two lines. A2 bar minus A1 bar dot B1 bar cross B2 bar equals 0. Now we will see Cartesian form of coplanarity of two lines. Consider line L1 passing through point A x1, y1, z1, and which is parallel to vector b1 bar a1 i cap plus b1 j cap plus c1 k cap, and there is another line L2 which passes through point B x2, y2, z2, and which is parallel to vector b2 bar equals a2 I cap plus b2 j cap plus c2 k cap. Then vector ab will be x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1. Now lines L1 and L2 will be coplanar when this vector ab bar dot this vector b1 bar cross this vector b2 bar equals 0. Now this is nothing but scalar triple product of AB bar, B1 bar and B2 bar, which can be written in the form of a determinant this x2 minus x1, this y2 minus y1, this z2 minus z1, this a1 b1 c1, this a2 b2 c2 equals 0. Therefore we conclude that lines L1 and L2 given in the Cartesian form will be coplanar when the determinant x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2 equals 0. So this is the condition of coplanarity of two lines L1 and L2 given in the Cartesian form. We have to show that the line x plus 1 upon minus 3 equals y minus 3 upon 2 equals z plus 2 upon 1 and x upon 1 equals y minus 7 upon minus 3 equals z plus 7 upon 2 are coplanar. And next we have to find equation of the plane to which these two lines belong. If these two lines are coplanar, then they will be either parallel or intersecting lines like this. Suppose this line L1 passes through point A whose coordinates are 1, 3, minus 2, and this line L2 passes through point B whose coordinates are 0, 7, minus 7, and the dr's of line L1 are minus 3 to 1 and dr's of line L2 are 1 minus 3 2. Now we know that these two lines are coplanar when the determinant x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2 equals 0, which will be 0 plus 1, that is 1, 7 minus 3, that is 4, minus 7 plus 2, minus 5, then minus 3 2 1 and 1 minus 3 2. This will be equal to this 1 into 4 plus 3 7 minus this 4 into minus 6 minus 1 minus 7 plus this minus 5 into minus 9 9 minus 2 7. So this will be 7 plus 28 35, 35 minus 35 0, which implies lines L1 and L2 are coplanar. Now we write equation of the plane containing these two lines. That will be determinant x minus x1, y minus y1, z minus z1, then this minus 3, then this 2, then this 1 and this 1 minus 3 equals 0. Now x minus x1 will be x plus this 1, y minus y1 will be y minus this minus 3, then z minus z1 will be z plus this. Solving the determinant, we write x plus 1 multiplied by 4 plus 3, then minus this y minus 3 into minus 6 minus 1, then plus this z plus 2 into 9 minus 2. So it will be, if we cancel this 4 plus 3 7, this minus into minus, that is plus 7, and this 7 equals 0, then we are left with this x plus 1 plus this y minus 3 plus this z plus 2 equals 0, which finally will be x plus y plus z equals 0. So this is the equation of the plane in which lines L1 and L2 lie. We have to check whether the lines r bar equals I cap plus j cap minus k cap plus lambda times 3 I cap minus j cap, and r bar equals 4 I cap minus j cap plus mu times 2 I cap plus 3 j cap are coplanar, and if yes, then we have to find the equation of the plane containing these two lines. Here we have this vector is a1 bar, this vector is b1 bar, this vector is a2 bar, and this vector is b2 bar. Now these two lines will be coplanar if a2 bar minus a1 bar dot b1 bar cross b2 bar equals 0. a2 bar minus a1 bar will be 4 minus 1 3 I cap minus 1 minus 1 minus 2 j cap. There is no k cap, so it will be minus of minus k cap plus k cap dot b1 bar is 3 I cap minus j cap cross b2 bar 2 I cap plus 3 j cap equals 0. Now the left hand side here is nothing but scalar triple product or box product of 3 I cap minus 2 j cap plus k cap, 3 I cap minus j cap, and 2 I cap plus 3 j cap, which will be a determinant 3 minus 2 1, then 3 minus 1. There is no k here, so 0. Then this 2 3, and there is no k here, so 0, which will be this 3 multiplied by 0 minus 0, that is 0, then minus of this minus 2, that will be plus 2, multiplied by 0 minus 0 will be 0, plus this 1 multiplied by 3 3s are 9 plus 2, so this will be 11, which is not equal to 0, which implies this line and this line, they are not coplanar. So there is no question of finding the equation of the plane containing these two lines. Now we will discuss how to find distance of a point from a plane. Consider a point A whose position vector is a bar, and we have to find distance of this point from a plane whose equation is r bar dot n cap equals p, where this p is distance of this plane from the origin O. We will draw another plane passing through the point A and parallel to the given plane, whose equation will be r bar dot n cap equals a bar dot n cap, and distance of this plane from origin will be mod a bar dot n cap. Hence, distance of point A bar from the plane r bar dot n cap equals p will be this distance given by mod of this p minus mod of this a bar dot n cap. This is how we can find distance of a point from a plane, this one. Now we will discuss how to find distance of a point from a plane. Consider a point A whose position vector is a bar, and we have to find distance of this point from a plane whose equation is r bar dot n cap equals p, where this p is distance of this plane from the origin O. We will draw another plane passing through the point A and parallel to the given plane, whose equation will be r bar dot n cap equals a bar dot n cap, and distance of this plane from origin will be mod a bar dot n cap. Hence, distance of point A bar from the plane r bar dot n cap equals p will be this distance given by mod of this p minus mod of this a bar dot n cap. This is how we can find distance of a point from a plane. This one. Here it is important that the equation of this plane should be in the normal form. Let's find distance of point A whose position vector a bar is 4 I cap minus 2 j cap plus 3 k cap from the plane whose equation is r bar dot minus 2 I cap plus j cap minus 2 k cap equals 6. Here we have a bar equals 4 I cap minus 2 j cap plus 3 k cap and the normal vector n bar is minus 2 I cap plus j cap minus 2 k cap. Mod n bar will be square root of minus 2 square 4 plus 1 square 1 plus minus 2 square 4, that will be square root of 9 or 3, and n cap will be n bar upon mod n bar, that will be 1 upon 3 minus 2 I cap plus j cap minus 2 k cap. Now the normal form of the equation of this plane will be r bar dot this n cap 1/3 into minus 2 I cap plus j cap minus 2 k cap equals this 6 upon this 3, that is 2. Here p equals this 2. Now a bar dot n cap will be 1 upon 3 into 4 I cap minus 2 j cap plus 3 k cap dot n cap, which is this minus 2 I cap plus j cap minus 2 k cap. This will be 1/3 of 4 into minus 2 minus 8 plus minus 2 into 1 minus 2 plus 3 into minus 2 minus 6, that will be minus 16 upon 3. So mod of a bar dot n cap will be mod of minus 16 upon 3, that is 16 upon 3. Now this required distance will be mod of p minus mod of a bar dot n cap, that will be this p minus 16 upon 3, which will be mod of 3 2s are 6 minus 16 minus 10 upon 3, that will be 10 upon 3. So this will be the distance of this point A from this plane, 10 upon 3. We will find vector equation of this plane which is at a distance of 5 units from the origin O and which is normal to the vector 2 I cap plus j cap plus 2 k cap. Now in this problem, this normal vector n bar is 2 I cap plus j cap plus 2 k cap. So first let us find unit vector n cap equals n bar upon mod n bar, that will be 2 I cap plus j cap plus 2 k cap upon square root this 2 square 4, this 1 square 1 plus this 2 square 4, that will be n cap equals this will be 3, so 1/3 2 I cap plus j cap plus 2 k cap, and the distance of this plane from the origin is given to be 5, which means we have p equals 5, and vector equation of this plane will be r bar dot n cap equals p. Therefore we write r bar dot n cap, which is this 1/3 2 I cap plus j cap plus 2 k cap, will be p, that is 5. So the required equation of this plane will be r bar dot 2 I cap plus j cap plus 2 k cap equals 3 5s are 15. If you like this video, please share this to your classmates. Don't forget to subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.